Welcome, everyone. Thank you for joining us for the 6th session of Ocean Acidification Week, a virtual multi-day forum to highlight ocean acidification research and initiatives. OA Week is presented by GOA-ON, the Global Ocean Acidification Observing Network, by NOAA, the National Oceanic and Atmospheric Administration, by the IAEA OAICC, the International Atomic Energy Agency, Ocean Acidification International Coordination Center, and by IOC-UNESCO, the Intergovernmental Oceanographic Commission of the United Nations Educational, Scientific, and Cultural Organization. This session will feature talks from around Latin America and the Caribbean. We are glad to have over 292 people pre-register for today's session. Currently, there are over 100 people joining the session, and we hope the rest will join very soon. My name is Michael Aquafreda, and I work with the GOA-ON Secretariat. I'm also a Knaus Fellow working with the NOAA Ocean Acidification Program. I will be moderating today's session. During the presentation, all participants are in listen-only mode. You are welcome to type any questions into the question box, which can be found at the bottom of the control panel on the right side of your screen. You can also pose questions and share your insights or ahas on Twitter using the hashtag OAWeek2020. We do ask that you specifically mention which speaker you're directing your question to. We'll be monitoring incoming questions and will pose them to our speakers during the question and answer section, which will begin immediately after the last presentation. Today's webinar is being recorded and will be available through the GOA-ON YouTube channel shortly after OA Week ends. Before we hear from our speakers, I would like to briefly share a little information about GOA-ON. GOA-ON is a collaborative international network designed to address 3 high-level goals. First, to improve our understanding of global ocean acidification conditions. Second, to improve our understanding of ecosystem response to OA. Third, to acquire and exchange data and knowledge necessary to optimize modeling for OA and its impacts. GOA-ON is an active organization that offers numerous resources to its members. GOA-ON informs policy at the international level. GOA-ON is involved with the Commonwealth Blue Charter and the UN Decade of Ocean Science for Sustainable Development 2021 to 2030. GOA-ON also assists with the UN Sustainable Development Goal 14 by helping to develop the methodology for the SDG indicator 14.3.1 by providing guidance on how to measure ocean acidity and how to report the collected information. GOA-ON also offers a scientific mentorship program through peer-to-peer. Peer-to-peer matches senior researchers with early career scientists to facilitate an exchange of expertise and to provide a platform for international collaborations. Scholarships and hands-on trainings are available through peer-to-peer. GOA-ON also hosts a data portal, which provides access and visualization to OA data and data synthesis products being collected around the world. Data are present from a wide range of sources, including moorings, research cruises, and fixed time series stations. Finally, and most recently, GOA-ON is kicking off ocean acidification. GOA-ON is kicking off a webinar series through Ocean Acidification Week. We welcome your inputs on future webinars that GOA-ON offers, and you could type those into the question box. GOA-ON has 8 regional hubs, and we'll be hearing from most of those hubs throughout Ocean Acidification Week. Overall, GOA-ON has over 750 members from over 100 countries. Become a member of GOA-ON today by visiting goon.org. One reason why GOA-ON decided to host OA Week is because initially, the 5th International Symposium on the Ocean in a High CO2 World was scheduled to take place this week in Lima, Peru. Yet, like many other events scheduled for this year, the symposium had to be postponed until 2021 because of the COVID-19 pandemic. This symposium would have brought together researchers, decision makers, and other stakeholders to share cutting-edge OA science. We're looking forward to that and hope everyone listening today will visit the symposium's website and learn more. We'll see you in Peru in 2021. Today, it's my honor to introduce the speakers from the LAOCA Hub, Cristian Vargas from Chile, Francisco Navarrete-Mier from Ecuador, Rodrigo Kerr and Carla Berghoff from Brazil and Argentina, respectively, and Wilmer Carbajal Vialto from Peru. Unfortunately, Alberto Acosta from Colombia could not join us today. Without any further ado, I'd like to introduce our first speaker, Cristian Vargas. Cristian, I've made you the presenter. You could share your screen when you're ready.
Okay. Perfect. Can you see my screen?
We can see your screen, and your screen is at full screen, so you could start your presentation whenever you're ready.
Okay, Michael, thank you. So, well, I really appreciate the invitation from the organizers to talk for a few minutes about something that I personally consider to have been one of the most successful experience of collaborative work in the region in relation to this scientific issue, which has been so much relevance for the entire world scientific community and decision makers linked with the ocean, so the Latin American Ocean Acidification Network. So firstly, I want to talk a little bit about some antecedents about LAOCA. LAOCA is the Regional Coordination Network for Ocean Acidification Research in Latin America. It was officially established in December 2015, and in some way it's a kind of official organism coordinating observing capacities in the region. At that time, we have defined a main mission for LAOCA, which is to communicate and strengthen the observing capacity of the ocean acidification process, as well as improving the comprehension of the potential impact of OA on marine populations, ecosystems, and their services provided to humans. I have to say that in some way, LAOCA is more than a regional hub or network for scientists. In general term, I think that it has been considered as a kind of organism coordinating and communicating relevant information to stakeholders and decision makers in each respective member country. And after 5 years, LAOCA Network consists of more than 60 members from 10 Latin American and Caribbean countries, including Argentina, Brazil, Cuba, Chile, Colombia, Costa Rica, Ecuador, Mexico, Panama, and Peru. So most of our members are working in one of these different research lines, but similar than in other regions, most of them are working mostly on experiments by the study of the biological response of different organisms to future ocean acidification conditions, and the study of the carbon chemistry and different ecosystems. And in this sense, Latin America, as you know, is highly diverse in terms of coastal environments. We have, areas of coral reef, coastal upwelling areas to the southern part of the Patagonia with fjords and glaciers. And it's in the communities working in different ecosystems, mostly in coastal ecosystem. But there are some researchers working in estuaries, fjords, river plumes, subtidal, intertidal areas, environments, coastal lagoons, coral reef, and there's a significant group of people working in upwelling areas. But there's an increasing community that is working also in the study of the open ocean condition. During the last year, we have accomplished several achievements, including which I can divide in 5 major points, including the articulation with other national, regional, and international programs, the training of a large number of young researchers, facilitate the student exchange among the members countries, and the organization of different courses for graduate students, and a significant component of outreach. And we have used different kind of, communicating facilities from TV channels, radio, seminars, webinars, and including also regular communications through social networks, including Facebook and Instagram. But also a very important component of LAOCA that LAOCA members and research groups in the region have produced a significant number of very interesting research papers, and some of those have transferred key scientific message not only to the regional community, but also to the international community. So I'm going in detail in some of these points. we have started our training activities, or the organization of the training activities in 2014, when the first LAOCA courses and in Dichato, which was focused mostly on basic aspects of ocean acidification research, including both biological components and carbon chemistry. Until 2 years later, we have replicated similar efforts by organizing a similar course in Ensenada in Mexico, focused especially in advanced students and early career scientists. But later, the same year, with the support of IOCCP and OICC, we have organized a training workshop for lab technicians and chemists, specifically focused on best practice in carbon chemistry analysis. Finally, in 2018, we have organized a new model of training activities, the first field training course in Galapagos Islands, where we have used natural CO2 seeps as analogs of ocean acidification process, and using different techniques, including also the use of stable isotope analysis. So more than 50 early career senior scientists were trained through these actions, and even some of the scientists which integrate our council, our executive council, were training through these actions organized and led by LAOCA. So probably one of the big differences of LAOCA with other international or national networks is the impact at multiple levels. Not only senior scientists, but also technician, undergraduates, graduate students. And during the last years, we have been trying to focus on science communicators. So we have organized different graduate courses, for instance, in Chile, about marine evolution in 2017, then in Costa Rica in 2018 about the application of stable isotopes in ocean acidification research. During the last year, we also organized a course on ocean acidification and the impact of benthic organisms in Guayaquil, Ecuador, a course that was led by Rafael Bermudez from Ecuador. So LAOCA also has tried to join the community in scientific symposiums, and the first of these symposiums was held in October 2017 in Buenos Aires, Argentina, where more than 80 participants from 12 countries showed their scientific results, including also countries outside the region, such as United States, United Kingdom, and France. So importantly, the Latin American region has produced a significant number of high standard scientific knowledge, and some of those studies have influenced in some way the international community. For instance, this paper about the call of attention about the importance of natural variability, for instance, in experimental design, or the study of natural analogs for evaluate the future ocean acidification condition by using the oxygen minimum zones in Mexico or in Peru or Chile. And recently in 2018, we have done the first characterization of the carbon chemistry in hadal environments, where a group of Chilean scientists collected samples at more than 8,000 meter depth, collecting samples for DIC and total alkalinity. So LAOCA activities are coordinated thanks to So another important issue is that the LAOCA is confirmed by a community with its own language, which is basically the Spanish and Portuguese. We talk with my colleagues that the LAOCA, we speak mostly in Portuñol, a mixture between Spanish and Portuguese, and have their own culture and regional identity. And recently, during the training course organized by the Ocean Foundation, we have finally evidenced the clear sense of belonging that regional community has with LAOCA, identifying it as the major coordination effort in the region. So LAOCA activities are coordinated thanks to the effort and dedication of an executive committee. During the first period, it was led by Leticia Dacuña and Nelson Lagos. During the last 3 years, Michelle Graco and Martin Hernandez Ayón were led LAOCA activities. In my case, I have been supporting this network mostly by linking LAOCA with other international programs like GOA-ON and IOCCP, where I was in the past also part of the council. So the committee is also conformed by a group of between 5 to 6 scientists from other countries, who rather than represent countries, they represent geographic areas or regions within Latin America. Recently, together with Carla Berghoff, we have accepted this big challenge of leading LAOCA for the next 3 years. Generally, the nomination of the chair is made within the executive committee based on the potential of international networking of candidates, both within the region, but also with other international programs, and especially the desire and commitment to lead a work plan for the following years. With Carla, we have assumed this chairmanship for less than a week. It's just recently, but nevertheless, we are very clear about some of the issues, some of the aspects that we need to reinforce in this new stage, and that we could summarize in 4 main points. The first one is try to make a big revision of the governance plan according to the current times, to try to refresh it, renew, and articulate in a way that it not only it highlight the LAOCA connection with other programs in other part of the world, but in the new stage, we would like to try to establish a more robust links with the governmental agencies in the regions, such as ministers or climate change office. And also, we are very clear that in this new stage, we would like to try to explore potential candidates, graduates and postdocs who wish to become LAOCA members, especially from Central American, Caribbean countries. During the past periods, LAOCA was mostly integrated by senior scientists, but we are very clear that we need young people feeling to be part of this regional network. And the communications is a very important issue. We will focus on improving communication with our members, with a major role of council members in communicating information to not only to the respective countries, but also in the regions. So we will try to implement a new website and a LAOCA newsletter. Potentially, we are planning also to organize maybe some webinars, in addition to be able to hold an open meeting a year with all LAOCA members, not only meetings with the council. A new format of teaching and training will be necessary. We have now experienced this situation with the COVID, and LAOCA will begin a new training and teaching strategy using online virtual platforms. And we need also to try to conduct more specific courses in aspect of chemistry, biology, and also socio-ecological system. So, and a specific group of LAOCA also is planning to work on the generation of protocols like carbon chemistry best practices, but in Spanish to be able to be used for some people in the community. But finally, personally, during the last year, we have realized the importance of having consistent and correct message to the decision makers. We have noticed that it seems that in some occasions it's not clear the difference between ocean acidification and natural availability, especially for those people not really immersed in the scientific community. And we need to be consistent that ocean acidification monitoring requires an ocean observing capacity longer than 10 years. And we need to make clear the difference in understanding natural variability, daily cycles, seasonal cycles, interannual cycles in carbon chemistry, with the long-term capacity needed for observing changes in the carbon chemistry driven by ocean acidification. So in some way, it is similar to monitoring, I say, ocean temperature with a CTD, and then mention to the authorities that we are measuring ocean warming. So if countries have to assume commitments for ocean observing, those must be long-term commitments, and we need to be consistent with the message. And LAOCA, we will try to assume this major role, and at least in the region. This is the same for the experiments. We need a new level of experiments. They can be sometimes simple. In other situations, they need to be complex but realistic, and that really contribute to evaluate impacts. So we would like to begin a new level of training activities to try to design with the community simple experiments, but they can really generate information that helps our ability to adapt to ocean acidification, including field experiments, transplant experiments, combining genetic tools, the study of the reaction norm as a basis to evaluate the adaptation potential of populations on environmental gradients, but experiments that represent the real world. Otherwise, we also run the risk of generating results that are in some cases speculative or they may be misunderstood or extrapolated by local decision makers in the region. So we have a new email in LAOCA, it's redlaoca@gmail.com, and we will try soon to have a new website that we will make available for all the community to be informed about all the activities that we are going to organize, hopefully during this period. Thank you.
Thank you so much for that presentation, Cristian. Our next speaker is Francisco Navarrete-Mier. Francisco, I'm going to make you the presenter now.
Okay, can you hear me, and can you see my screen?
Yes, we could hear you and we could see your screen. It's full screen. You could start whenever you're ready.
Okay, Mike, thank you very much. Well, good afternoon, everybody. I'm really glad to share this presentation with you, and this presentation is made in collaboration with Celeste Sanchez Noguera and whole this team of researchers working in the tropical area. So let's make a tour for this tropical America area. And regarding to the chemistry of the state of the art, as you can see in the pattern of colors, there are differences between capabilities between countries. So, but in general, we could say that now we are measuring the natural variability, and we are running a short-term monitoring for the moment, and we are building our very first baseline in every of the ecosystem that we have in the area. Regarding to the biological experiments, also different countries has different capabilities, but in general, we could say that we start to working in lab with just one stressor, mainly focused on development and growth, and we are working at species levels. In the next future, we want to expand this kind of experimentations, and also very soon they will deploy a fossil system, so they will be able to work at community experimentation also. Now, let's make a tour for these countries. Regarding to Mexico, we know that Mexico has all the capability to analyze chemical carbonate system in seawater. So they are applying these capabilities to monitoring. We could share this work in the Gulf of Tehuantepec, where the researchers teams has worked with the upwelling areas and has a really nice results of how the low pH water and subsaturated water reach the coastal areas. Also in the Mazatlan laboratory, since 2016, they have 10 monitoring stations, and they measure pH and alkalinity, and has a really nice, interesting students with that. Also, I like to highlight these coastal observatories of global change, and then is working in Mexico in both sides of the country, and they are monitoring in the Pacific, in the Gulf of Mexico, and in the Caribbean. Now we could move to Guatemala, and Guatemala in the Atlantic coast, they are focused on how ocean acidification could impact the reef, coral reef health, and they are analyzing especially the bleaching events of the corals. And in the Pacific coast, they are monitoring the system, especially focused on the phytoplankton, and they are measuring one parameter, pH, with the main outcome at the end to see the impacts on fisheries. Now, we could move to Cuba. In Cuba, they have a laboratory in the Environmental Research Center of Cienfuegos, with all the capacities to analyze carbonate chemistry, and also mass spectrometry to analyze isotopic DIC. With this, they could run several field measurements, has equipment to monitoring continuously, and also analyze the calcification rates in coral ecosystems. And also, I would like to highlight the work they are doing in the reconstruction of historical trends of pH with analysis of sclerochronology in the corals. And also, they are ready to start some biological experimentation focused on mainly in shrimps related to aquaculture. So now we move to El Salvador. El Salvador is beginning with this subject, and they are participating in several programs, and they are in the process of construction of capacities, and they are training their scientists, especially to monitoring ecosystems related to rocky reefs, and they start to measure some areas with just pH. Okay, now we move to Costa Rica, Pura Vida, and in Costa Rica, they have the capabilities to analyze pH and total alkalinity, but also has the equipment to monitoring in situ and continuously. And with these equipments, they could make a really nice baseline of the upwelling system and the not upwelling system, both in the Pacific and Caribbean. And also, they are starting to run in some experiments, biological experiments with sea urchin larvae and oysters. But in the next future, they will also start to working with fishes in biological experiments. That is really cool. Now we move to Panama, and Panama is interested to monitoring both sides of the country, Pacific and Caribbean also, on Atlantic. And they are able to measure several variables in this carbonate chemistry system. And I would like to highlight the work in the coral reefs. They are ready to deploy a FOSSE system in the Galeta Marine Station. So we could, in the next future, we could hear really nice results from that. Also, they have a funding project, that is congratulations for that, to analyze the carbonate chemistry in the mangroves area. That is a really important ecosystem for the region. And they will plan to focus on the biological response of this clamp, Anadara tuberculosa, which is a very relevant species for the local fisheries and for the local communities. Now, we move to Colombia, where INVEMAR has a really cool lab with all the capabilities to analyze the chemical parameters of ocean acidification, but also are trying to start, or have started with a research program and monitoring program both in the Atlantic and the Pacific. Also, they highlight the studies of carbonate chemistry in seagrass ecosystems, and that in the next months they could start a collaboration with the Army to do some research of the carbonate chemistry in the oceanographic cruises. And now we reach Ecuador, where Ecuador has among the first countries in the region to have a public policy framework for ocean acidification. So this subject is in the national environmental law. That is at least a really cool frame to work. And also we have started a baseline and monitoring program with 2 coastal stations at 10 miles of the coast. And we have the very first results for the area, so we are really happy. But also I would like to highlight the work done in Galapagos Islands, especially to measure and monitoring these CO2 bands around Roca Redonda Islet. That is pretty cool work. And also in our lab in Manta, we have the possibility to analyze the biological responses. And we have been focused especially on white leg shrimp and how the ocean acidification or low pH condition could affect in different levels in the several phases of development. And we also work with another taxa of relevant species. So in this point of the presentation, I would like to introduce you Remarco Network. That is a project financed, it comes from a project financed by the International Atomic Energy Agency, and includes 18 countries to monitoring, for oceanographic monitoring of several questions, also include ocean acidification, with the final outcome to reach decision makers that we know that is very important for the region now. And also, this program has has planned to set up this observatory of coastal acidification with several stations reporting for the SDGs. So now we could say we are pulling together, and it's not other option. So we have to work, and we are working with our local institution, collaborating between scientists in the region and with the international framework. So we know that this is the path to follow for the next years, and we need to collaborate with different networks in the area. So now at this point, this is the commercials. As Mike said, then the next year, Lima will hold the High CO2 World Congress. So we hope to meet you there. We expect to share some science with you, and also we could share a really good ceviche in Lima. So thank you very much for your attention. I would like to especially thanks to this team of researchers working in the region, but not just in the tropical region, in general in Latin America, that are facing a lot of problems, especially in funding and bureaucracy and several problems that we have every day in our countries, but still we are doing really nice and cool science, good science. Thank you very much for your attention.
Thank you so much, Francisco. I am very excited about the ceviche in Peru next year.
For sure.
All right, I'm going to make Rodrigo the presenter, and for our next talk, we're going to have two speakers, Rodrigo Kerr and Carla Berghoff. Rodrigo, you are now the presenter.
Okay, can you hear me?
Yes, we could hear you. Carla, you could go ahead and unmute yourself as well.
I will keep my camera off.
And we see your presentation, Rodrigo.
It's in full screen now?
Yes, it is.
Yes. So, okay, hello everybody. I'm Rodrigo Kerr from FURG, and together with my colleague Carla Berghoff from INIDEP, we will now present some review about the OA on the Western South Atlantic Ocean. So we are moving south and east from the previous presentation. So the Western South Atlantic is bordered by Brazil, Uruguay, and Argentina coastlines. The tropical area is dominated by the Northern Brazil current system, linking the South and North Atlantic on upper levels. The subtropical zone is driven by the Western current system, dominated by the Brazil currents and the Brazil-Malvinas confluence zone, regions of higher energeticity and one of the sources of South Atlantic central waters. The region is also impacted by freshwater discharge and local seasonal upwelling of central waters. Thus, the studies on the Western South Atlantic Ocean has a huge importance on regional and global carbon budget and flux, essential for the scientific community to better comprehend the OA process and impacts on local environment, society, and economy. Although the importance for OA studies, as we can see in the figure, the region is still an undersampled area regarding the carbonate system parameters and long-term time series to assess OA. So what we already know about OA in the Western South Atlantic Ocean. In fact, if you look to the table, we have very low knowledge about the OA status, mainly because the regional time series from the region are not long enough to infer about OA. However, we know about the main patterns of CO2 behavior, with the tropical zone acting as a CO2 source to the atmosphere, and the south zone mainly acting as a CO2 sink to the ocean. The South by Brazil Bight is swinged between an equilibrium to a thirsty region. Although that, we still have little information about the spatial temporal variability and drivers all along the western South Atlantic Ocean coastline, which makes it difficult to infer about OA. One thing to highlight is that the central waters of the South Atlantic Ocean is acidifying faster than other surface or intermediate water mass in this ocean. And the central water sourced in the Brazil-Malvinas confluence zone is the region of arids that upwells in the South Brazil Bight. Splitting the regions into 4 main biogeochemical provinces and comparing the knowledge among them, we have a relatively low level of knowledge on the tropical Western South Atlantic. However, several recent studies detailing the spatial-temporal variability of the CO2 system parameters in the area, identifying that regions under larger river influences can swing between CO2 source and sink, depending on the season of the year. Also, the knowledge about the CO2 system on the tropical estuaries along these provinces are the higher we have when compared to other similar environments along the Brazilian coast. A recent review study was published and highlights the physical and biogeochemical knowledge on the open ocean tropical Atlantic. Regarding the South Brazil Bight and the South Brazil Bight and the Southern Brazilian Shelf, they are among the regions that we have less knowledge about the CO2 system dynamics, variability, and chance. As previously said, this region is impacted by the Brazil current systems, while upwelling of central water masses occurs in its northern boundary. As this upwelled water has a more recent contact with the atmosphere, these waters can carry more anthropogenic carbon and faster impact the regional ecosystem more drastically. This effect can be intensified if we consider the whole of the Agulhas eddy traveling along the South Atlantic Ocean that can achieve the region, as those mesoscale structures can intensify the CO2 uptake along their trajectories and transport more anthropogenic carbon than the surrounding waters. So some recent efforts are underway to understand both the spatial temporal variability of the CO2 system and the process behind the OA in this area. Finally, those recent studies bring light to a better comprehension of the CO2 system and the OA in those regions, which is really important when we figure out that the region is marked by OA-sensitive environments, such as the coral reefs and the rhodolite beds all along the Brazilian coastline. Some of these ecosystems are also suffer from other climate anthropogenic stressors, which also highlight the urgent needs to increase the studies regarding OA. To conclude this first part, the interface between estuaries, coast, and shelf are also key zones for the life of marine organisms and the economy in the region. Thus, should receive a better attention by science, stakeholders, and politicians. Okay, now Carla.
Thank you. I'm gonna say you next when I need it, okay? So regarding the Argentine area, the Central Shelf has medium knowledge. Why? Although it's really a complex idiography area, because it has the affected waters of the subantarctic origin and La Plata River discharge, which is the second most important river in the area. It also has the influence of the Malvinas Brazil current, as Rodrigo mentioned, but also the key feature of our region, which is the shelf break front, and also the subtropical shelf front. Several cruises were heard in the area, but few recent studies have reported some spatial temporal variability of the carbonate systems in the region. Likely, we just start some new time series. Well, we include CO2 measurements in the region and ATPA time series and coastal transect. Next. So, although Central region is not that known as the Patagonian Shelf, which is really well known in a huge perspective, being this area one of the largest and more productive areas, and being the biological pump playing a dominant role in the CO2 dynamics. This area has, although seasonal heterogeneous variations, it's one of the strongest CO2 sinks area. And also, as Rodrigo mentioned, since it has a lot of, how can I say, dominated by subantarctic waters, it's a key area for anthropogenic in the region. And it's been established that anthropogenic carbon has intruded until but also, as Rodrigo mentioned, annual pH reduction of this area has been getting faster, not only in the Patagonian shelf, but also in the shelf break, comparing to other regions. Next. So all of these studies that I previously mentioned were held mostly during the last decade. But nowadays, there are recent initiatives being established in the Argentine area, mainly dealing with the establishing an ecological fixed time series monitoring network all along the coast of Argentina, which is called Roma. And some of these sites, apart from EPEA and Costal, will include carbon system measurements, but also there's just been recently established an underway PCO2 monitoring held by the RV Victor Angelescu from INIDEP. But how about the experiment? Regarding the experiments, several researchers from all around Argentina are getting its first steps, working not only in the central shelf, but also in the Patagonian shelf and even in Ushuaia and the Astral Zone, working at the species level on important both ecological and economical species like scallops and several crustaceans and austral fish in the region. Mostly they are getting trained and acquiring infrastructure needed to carry out those experiments. But also there are some groups working on primary and secondary producers carried out multi-stressor experiments in northern Patagonia. Next. In addition to the Western South Atlantic Ocean environment, Brazil mainly is also investigating ocean acidification in the Atlantic sector of the Southern Ocean. Recent Brazilian efforts have better characterized the seasonal variability of the carbonate system on coastal zones on the northern Antarctic Peninsula and identify that the summer CO2 sink has been intensified since 2012. Also, both anthropogenic carbon intrusion and a long-term pH decreasing trend is being observed in the coastal sector on the northern Antarctic environment. Several studies are underway to better understand this. And, but okay, so this is our general knowledge about the area, but what are our weaknesses and what we can do to get a larger perspective on the things that we don't know yet. So we have a large knowledge on the spatio-temporal variability on the carbonate system. We have a huge area, but although some efforts from Pirata, Sincosta, Samoca, and EPEA are running, it's still difficult to get an understanding of the drivers and responses of OA in this region. And these prevent us to identify vulnerable and impact marine organisms that needs to be better identified. But also, we have practically non-existent modeling or reconstruction efforts that really must be strongly identified in order not also to predict future changes in biology and in the socio-economic aspects, but to identify vulnerable areas to OA. Another key thing is that since this topic is recently established in the region, we have very young or recent researchers working on ocean acidification studies, which is good. But however, we need to build more capacity in the region and continue monitoring. In our region, ocean acidification is still kind of an abstract concept. And we need to reinforce both regional and local efforts to fill the gap and get a better dialogue with society, politicians, and stakeholders. Next. So as we say, we have, and also as Francisco says, we have many things, many strengths and many things to work it out. But I think we have a really nice researchers working in the area, and soon we are going to get really nice results. And also, as Francisco says, time for invitation to the High CO2 Symposium next year, and I wish we can join a nice ceviche together. Here we have also the BROA and the Red LAOCA email to contact us if you need, and also thanks all the colleagues that help us to build this presentation.
Thank you so much, Carla and Rodrigo, for that wonderful presentation. At this time, I'd like to remind the audience that if you have any questions for Cristian, Francisco, Carla, Rodrigo, you could put those questions into the questions box. And now I'd like to introduce our final speaker for today, Wilmer Carbajal Villalta. Wilmer, I've now made you the presenter. Wilmer, can you unmute yourself? We could see your screen.
Yeah.
All right, Wilmer, you're good to go whenever you're ready.
Bien, en primer lugar, quiero agradecer a Cristian, Michelle, Nelson y los otros colegas que aparecen más abajo por haber compartido parte de la información con la cual se organizó esta presentación. Voy a referirme, de manera de introducción, al Océano Pacífico Sureste. En esta parte del Pacífico se localiza básicamente el gran ecosistema marino de la corriente de Humboldt, que es un sistema de corrientes mayormente superficiales que discurren de norte a sur, desde los 45 grados del sur hasta los 4 o 5 hacia el norte, ¿no? A lo largo también de la costa sudamericana se encuentran grandes ciudades, mayormente el 70% de la población de cada país se encuentra en estas zonas, obviamente produciendo contaminación, incrementando los gases de efecto invernadero, especialmente el dióxido de carbono, lo cual conlleva obviamente el calentamiento global. Y por otro lado, también es importante mencionar que en este gran ecosistema se localiza lo que es la zona de mínima de oxígeno, que afecta principalmente a Perú y un poco en menor grado a Chile. También la presencia del evento El Niño es un factor importante cuando queremos hablar del sistema de carbonatos, y algunos otros aspectos relevantes como los afloramientos costeros y la descarga de los ríos, de los estuarios, fiordos, que nos van a dar un panorama más adelante de cómo ellos influencian en la gran variabilidad que existe en el pH y en el CO2. No está de más indicar que a lo largo de esta costa sudamericana se desarrolla la industria de acuicultura de varias especies pacificadoras, como lo vamos a ver en las próximas diapositivas. Bien. Voy a enfocar en 4 aspectos fundamentales de la exposición para ver cuáles son los avances, cuáles son los vacíos y cuáles son los desafíos que tenemos enfrente que superar para tener un mejor conocimiento de la acidificación y su impacto en los ecosistemas tanto costero como oceánico, el sistema de Humboldt. En Chile, principalmente, ya ha quedado demostrado en bases de investigaciones que existe una alta variabilidad del pH y del CO2. En la parte norte, centro-norte, como ustedes pueden observar, básicamente esa variabilidad obedece a procesos de afloramientos costeros, ¿no? Que son datos que han sido tomados a través de campañas oceanográficas de algunos meses y durante algunos años, entre Antofagasta, Iquique, por ejemplo, ¿no? Y también tenemos que esa variabilidad de pH y de CO2 ocurre en la parte centro-sur de Chile, básicamente debido a la influencia de ingreso de agua dulce, de los estuarios, de los fiordos, en fin. Y esto básicamente hace de que se produzca lo que ya mencionó Cristian al comienzo, una gran variabilidad natural realmente de los valores de pH y de CO2. Al final de cuentas, los resultados que encuentran los investigadores chilenos es que en la parte norte de Chile, centro-norte de Chile, actuaría como fuente de CO2 y en la parte final, en la parte ya de los glaciares, actuaría como sumidero, principalmente por la entrada de agua dulce, donde ocurre una alta productividad. En el caso de Perú, de manera casi similar, también se observa una alta variabilidad en el pH y en el CO2, es decir, bajo pH y alto CO2. Pero aquí, a diferencia de Chile, básicamente esto ocurre por la presencia o la ocurrencia de surgencias costeras estacionales a lo largo de todo el año y a lo largo de la costa peruana. Podemos observar valores de 7.5 en la parte norte y también en la parte sur, principalmente en esta zona. Aquí aparentemente nos hace pensar de que existe la presencia, ocurrencia de EDIs, de mesoescala, que se encargan de distribuir las aguas como bajo pH hacia la parte oceánica, por ejemplo, ¿no? Por otro lado, en la costa peruana también se ha observado que existe un alto flujo de CO2 hacia la atmósfera. Es decir, es que la parte del mar peruano se estaría comportando permanentemente como fuente de CO2, ¿no? Tenemos valores hasta de 10 o más moles de CO2 por metro cuadrado por año, ¿no? Y también algunos valores más bajos, pero que obedecen a la alta productividad biológica que existe en el mar peruano. En conclusión, entonces, tenemos que el mar peruano se comporta como fuente de CO2. Por otro lado, también el IMARPE, el Instituto de Mar del Perú, tiene previsto establecer 4 estaciones fijas a lo largo de la costa peruana, donde se encuentran sus laboratorios costeros para tomar datos de pH y de CO2 y relacionarlos realmente con la ocurrencia, por ejemplo, del Niño, así como los vientos favorables de los afloramientos y los cambios de productividad y las masas de aguas que se presentan en este ecosistema. Se están haciendo esfuerzos también en el norte del Perú para hacer un monitoreo del sistema de carbonatos, algunas variables como el pH y la alcalinidad total, en zonas de área de surgencia o de afloramiento, como lo es frente a Pimentel y frente a Chirrepe, donde mayormente los ríos que tienen descargas estacionales en verano o cuando hay el fenómeno Niño que podrían estar afectando estos ecosistemas, como por ejemplo acá, en el mes de febrero o marzo, tenemos hasta aquí la estación 5, que es lo que ustedes observan acá, una mezcla de agua dulce con agua salada misma, y que afecta realmente el pH, por ejemplo, ¿no? El otro aspecto importante que hemos considerado son los impactos de la acidificación sobre los organismos marinos, ¿no? Principalmente a través de experimentos. Que estamos mostrando aquí cómo es que los colegas chilenos, por ejemplo, han investigado los impactos del pH y del CO2, principalmente, en algunos organismos calcificadores, como por ejemplo Mytilus chilensis, concholepas, tenemos el erizo, Argopecten purpuratus, también lo han hecho en Perumytilus purpuratus, también lo han hecho en Mytilus, bueno, en Mytilus chilensis y Mytilus gallos provinciales, por ejemplo. Y básicamente lo que ellos han abordado es el tema del impacto sobre el crecimiento, las tasas de calcificación, las tasas fotosintéticas de algunos organismos planctónicos, el metabolismo principalmente, ¿no? De hecho, ellos, en base a todos estos experimentos que han realizado, tienen un porcentaje alto de publicaciones realmente, del total de Sudamérica, creo que el 62% son publicaciones de experimentos en esta parte de Chile. Es bueno también indicar de que comenzaron trabajando con el pH, CO2, pero en la medida que iban haciendo nuevos descubrimientos, ellos han ido incrementando otros factores, otras variables, de tal manera que ahora se analiza en un contexto del impacto de estresores múltiples realmente, ¿no? En el Perú se han realizado algunos estudios experimentales, como por ejemplo el de Conchabanico, ¿no? Y relacionado con el efecto del pH sobre el crecimiento y la estructura mecánica de las valvas de esta especie, como estamos viendo acá. Y lo más resaltante es ver como, por ejemplo, la dureza de la concha de abanico más bien se incrementó con un pH bajo, por ejemplo, ¿no? También se ha visto el desarrollo larval del erizo de mar en dos concentraciones de CO2 a 1000 partes por millón y a 400 partes por millón, donde hay una diferencia significativa en la morfología de las larvas de erizo, realmente, ¿no? En relación a estudios observacionales, tenemos que frente al Callao, en latitud 12 grados, hay una boya que está tomando datos de CO2, de presión parcial de CO2 y de pH. También se ha hecho un estudio del sistema de carbonatos entre Callao y Pisco, donde se observa como el pH es alrededor de 7.5, sobre la parte costera principalmente. ¿Ya? También se han hecho estudios de la distribución y abundancia de las mariposas marinas, terópodos, frente al Callao, y se ha demostrado, por ejemplo, de que estos organismos se alejan cuando el pH es bajo, y cuando el pH se vuelve más alto, se acercan hacia la costa. Por el otro lado, también se han hecho estudios para ver más o menos cuál ha sido la tendencia en los sedimentos, la presencia de foraminíferos calcáreos en la parte de Pisco, y también se han hecho estudios de la distribución y abundancia de coccolitofóridos en la zona frente al Callao, en Perú. Tenemos la parte costera, donde el pH es más bajo, y la parte oceánica, con valores más altos de pH. Y lo más importante es que se encontraron 3 morfotipos de esta especie, ¿no? En el 2017 y el 2020 se desarrolló un proyecto integrado por Geomar y el Instituto del Mar de Perú, en donde se simuló el afloramiento para ver cuáles son los impactos de la acidificación y de la desoxigenación sobre la propiedad comunitaria, así como sobre la estructura de la trama trófica, ¿no? Para ello, se llenaron estos mesocosmos hasta el 70% de agua superficial, y luego se agregó un 30% de aguas tomadas de zonas de mínima de oxígeno para ver y simular, como les digo, el afloramiento de aguas profundas. Bien, en relación al otro aspecto del modelamiento, bueno, esta es realmente la parte más deficitaria que se encuentra en la parte de la corriente de Humboldt, como ya lo han mostrado también en la parte de Argentina-Brasil. No existen series de tiempo de largo aliento que sean de 10, 15 o 20 años mayores, solamente se están tomando datos de campañas de cruceros con una escala, digamos, estacional o anual o interanual, lo cual, como ya se mencionó anteriormente, solamente nos dice qué está pasando con la variabilidad del sistema de carbonatos, pero no nos sirven esos datos para ver qué va a ocurrir realmente con el aspecto de la acidificación como consecuencia del cambio climático mismo, ¿no? Entonces, requerimos de esa información, de nuevos proyectos que nos permitan obtener o ir incrementando los datos, de tal manera que en algún momento podamos llegar a simular cuál es, por ejemplo, el estado de la saturación de la aragonita en esta parte de acá, de la corriente Humboldt solamente, ¿no? De Perú y Chile, ¿no? o también de los flujos del CO2 al océano, por ejemplo, ¿no? Entonces, con modelos, aplicar modelos acoplados de cambio climático, por ejemplo, globales. Entonces, requerimos esa información que por ahora no la tenemos disponible, ¿no? Un aspecto también que es muy interesante e importante es el tema de la acidificación del océano y la acuicultura. Ustedes pueden observar acá cómo es que tenemos diversos organismos invertebrados calcificadores como argopecten, cangrejo violáceo, mitílidos, concholepas, acá también en Chile lo mismo. Entonces, y básicamente todos ellos se distribuyen en bahías donde ocurren las urgencias o afloramientos costeros. En este contexto, por ejemplo, en Chile, aquí estoy mostrando dos publicaciones del año 2020, ¿no? Que habla de la dinámica de la química de los carbonatos, por ejemplo, en algunos moluscos, como es la Argopecten purpuratus, por ejemplo, ¿ya? Y también en Semimitylus, ¿no? Donde comparan la presión parcial de CO2 a través de las estaciones del año y la tasa de crecimiento. Y acá abajo, por ejemplo, vemos en mitílidos también cómo es que se demuestra que a una profundidad de 4 metros se obtiene el mejor rendimiento de las semillas de estos mitílidos, de estos choritos, ¿no? En condiciones de experimentos in situ. Y un tercer aspecto que es importante es algo que ellos se vienen estudiando en esta parte del Pacífico, es la importancia de los niveles de plasticidad fenotípica en los organismos marinos frente a cambios como la temperatura y el CO2. Es decir, se está viendo cómo las variables ambientales afectan el genoma de estos organismos de tal manera que producen un cambio en el fenotipo como una manera de enfrentar o de adaptarse a las condiciones cambiantes del clima. En el caso de Perú, todavía se ha avanzado poco en este aspecto. Aquí en el norte se realizó un trabajo de la acidificación, sobre el efecto de la acidificación sobre la calcificación de Argopecten purpuratus en la bahía de Sechura. La bahía de Sechura es una de las más grandes del Perú y que produce hasta el 80-90% de Argopecten purpuratus de todo el país, generando hasta 100 millones de dólares en exportaciones, ¿no? Y dando trabajo a más o menos unas 10.000 familias, ¿no? Aquí observamos cómo se da la variabilidad del pH en relación al carbonato de calcio de las valvas de concha de abanico. Y lo que hay que resaltar es que aquí hay un componente nuevo, que es un estuario que estaría afectando la dinámica, digamos así, del sistema de carbonatos, ¿no? El sistema de carbonatos en esta bahía. Ahí en realidad es un laboratorio natural donde se puede hacer, se debe hacer investigación no solamente de escala corta, sino también de largo aliento, ¿no? Bien, como conclusiones, yo me permití hacer una tablita sobre un FODA de fortalezas, oportunidades, debilidades y amenazas. Bueno, entre las fortalezas que tenemos, instituciones como la NOAA, el Organismo Internacional de Energía Atómica, tenemos la Comisión Intergubernamental Oceanográfica, que están contribuyendo al conocimiento de la acidificación, pero también tenemos instituciones que están contribuyendo con el financiamiento de capacitaciones, de organización de eventos, como el quinto simposio internacional sobre el océano, por ejemplo, como es la Fundación Príncipe Alberto II de Mónaco, y bueno, y tenemos también una gran fortaleza con los núcleos regionales del GOA-ON. Otra cosa que también nos fortalece y nos dicta un poco el rumbo a seguir es el gran número de publicaciones científicas sobre experimentos que se han realizado en Chile, por ejemplo, ¿no? Eso nos motiva para seguir avanzando en este tema. Y bueno, como oportunidades tenemos que podemos integrar a los actores o los grupos de interés involucrados en la acidificación oceánica, al gobierno, las universidades, los maricultores, a la industria acuícola, por ejemplo, ¿no? También es una oportunidad para mejorar la comprensión de las respuestas de los clasificadores de importancia económica, como por ejemplo concha de abanico, los choritos, el loco, etcétera, ¿no? Y también, indudablemente, podemos para contribuir al desarrollo de la acuicultura. En las debilidades tenemos una lista un poco más larga realmente, ¿no? Ahí tenemos que tenemos ahí un déficit de equipo, por ejemplo, de equipamiento, en el caso de Perú. También existen pocos estudios de modelación, como Perú-Chile. Faltan más investigaciones experimentales, como el caso de Perú. Faltan una serie de tiempo de largo aliento, como Perú-Chile. También existe una débil gobernanza sobre este tema de la acidificación en los países como Perú y Chile, y una poca participación del aspecto socioecológico y socioeconómico dentro de los estudios de acidificación. Bien, en las amenazas, indudablemente que el incremento de emisiones de CO2 es una de las más importantes. Tenemos también el fenómeno del Niño, ¿verdad? Tenemos los afloramientos de aguas corrosivas, ¿no? Está ocurriendo, como ya lo hemos mostrado al comienzo, y la presencia de las zonas de mínima de oxígeno y también la contaminación. Aquí estoy mostrando las universidades y centros de investigación de Perú y Chile, que hasta el momento están involucradas en la investigación de la acidificación del océano. Y bueno, no queda más que invitarlos al 5º Simposio Internacional sobre el océano en un mundo de alto contenido de CO2, que se realizará en septiembre de 2021. Y bueno, existe ya mucho interés. Lamentablemente esta pandemia cortó un poco la viada que teníamos para hacer este evento, pero estamos ahí con las mismas ganas, el mismo entusiasmo para realizarlo el próximo año. Muchísimas gracias.
Gracias, Wilmer, for that great presentation. We have plenty of time for questions, so I'm going to become the presenter again. And before we get started with the question and answer section, I first would like to remind all of our audience members that if they have questions, please type them into the questions box. You also could pose your questions on Twitter using the hashtag OAWeek2020, hashtag LAOCA, hashtag Latin America, and you could @GOA-ON. If there's any questions that we don't get to today, we will continue the conversation on the Ocean Acidification Information Exchange. If you're not already a member of the OAIE, I highly encourage you to check out the website oainfoexchange.org and become a member. And before we start the question and answer section, I do want to plug the last 4 sessions of Ocean Acidification Week. Day 3 kicks off tomorrow with the Northeast Atlantic Hub Part 1. That will be focused mostly on observing and monitoring. And then the second session is the Northeast Atlantic Hub Part 2, which is focused more on biology. Session 9 of Ocean Acidification Week will feature partner organizations of GOA-ON, like the Ocean Foundation, the Ocean Alliance, MBON, and GOOSE. And then finally, we'll have the capstone presentation where we'll hear from the co-chairs of GOA-ON, Jan Newton and Bronte Tilbrook. And we also will hear from a co-chair of the High CO2 meeting, Jean-Pierre Gattuso. So at this time, if the panelists would like to turn on their cameras, we could begin the question and answer session. All right, I will bring up some questions. So the first question is from Nelson Lagos, and it's directed at Rodrigo. He wants to know, how is the net balance between CO2 sink and outgassing areas for the overall region of the Atlantic? I think you might still be muted.
Yeah, it's now okay.
You're okay. Yeah.
Could you repeat the first part of the question?
Yeah, the question is, explain the balance between CO2 sinks and outgassing areas in the overall region of the Atlantic?
Yeah, because as we show, the tropical area, the surface water is warmer, so probably temperature are working on emission of CO2 in that area. And also in the Patagonian shelf and more south regions of the South Atlantic Ocean, we have a lower temperature, low surface temperatures, but also higher biological primary productive, so intensifying the CO2 uptake in those regions. In the middle between the tropical area and the more subantarctic and Antarctic zone is a region that sometimes the area responds as an equilibrium between the CO2 in the atmosphere and in the ocean, and sometimes it's working more as a source of CO2 to the atmosphere. But there is a lack of the seasonal variability that we don't know in the region. So it's difficult to make a balance and better characterize. So the coastal is sinking or surging, and the open ocean is sinking or surging if we are considering each of the biogeochemical provinces, because we lack the seasonal variability, the interannual variability. But the majority part of the studies that we have now show that more close to the coast, we have in the tropical and also in other parts of the coastline of the South America, the region, the coastal area work as a CO2 emission to the atmosphere. And in this coastal region, this is because we have influence from continents and the other process working together. I don't know if Carla would like to add something that I didn't talk on that. Your phone, Carla. It's not there.
Sorry, now? So no, I only wanted to ask, like, in general, like in the southern part, like in the Patagonian area, we have quite knowledge that it has strongest seasonal variations, but we don't know exactly in the coast. We know some parts emit CO2, but we really need to focus on study that regions and in the central shelf, but also in high latitudes, as Rodrigo mentioned, that high latitudes are just beginning to be on the agenda to be studied.
Thanks, you two. This next question is for all of our panelists, and it comes from Pablo Fernando Filippo. The question is, do you think that countries and governments in Latin America are perceiving ocean acidification? And to what extent are Latin American governments funding OA research and public policy? I think Francisco talked a little bit about that with respect to Ecuador. So Francisco, do you want to go first?
Okay. Well, I think in general, the governments are much involved in this subject. But there are few persons in the governments that are raising awareness about this subject and start to trying to make some things. For example, when we reached the National Assembly of Ecuador, there was a sum of different things that happens in the moment that we could reach to the National Assembly and at some point to present the situation. And we are very surprised when they say, okay, this is important. Let's do it something. Let's put this in the national law and let's see how it works. That is one thing. Still, there is not the real interest. Maybe in the region or in some countries at least, we have another priorities that requires most urgent attention. So this needs to be a framework built to try to convince the people in the decision makers that it's not a problem for now. It's a problem that we will face in the next years, and this will be not good for whole the economical situation. And when they make the click with that, maybe we could get more into them. Maybe the other colleagues could share.
Yeah. Does anyone else want to add? And Pablo also added a caveat at the end, asking specifically with respect to fisheries. So, Francisco, you mentioned economic issues, sometimes being the light bulb that goes off on politicians' heads. So does anyone else want to add about how OA factors into fisheries policy for Latin American countries?
Can I add like something but a sketch? Like,
sure.
We don't have a legislation. We don't have yet reached top levels of stakeholders. Now, like, it depends on the country. Now, Argentina is rebuilding our oceanographic and marine system. So first we need to strengthen that part and then to work on the legislation, because if we are not coordinated together working as an Argentinian country, not in regions, you know, we cannot reach stakeholders and give them the accurate information for them to be clicked. If we are a pool of people working on that, I think that's why we need to join, as we mentioned, both local and regional, you know. I think that's key part. Mainly in Argentina. Argentina, it's one of the main fisheries areas in the world, and we just start thinking of monitoring. We just started to. So we need to embrace that part first and then to transmit to stakeholders. This is my point of view. It's my personal point of view.
Yeah, but like, just add some few phrases about it. So the other important issue is that, at least that from our experience in Chile, is that aquaculture, in the case of the aquaculture and fisheries, for aquaculture, most of the shellfish farmers, they are facing problems at that time scale, which is shorter than ocean acidification. So, for instance, in southern part of Chile, I mean, aquacultures are very worried about harmful algal blooms, you know, and different problems that are occurring at time scale than, you know, 2 years, the next year, probably this seasons. And it's difficult when you don't have evidence, you know, to show to the decision makers about the progress of ocean acidification. I remember, I mean, just the last month, our Minister of Science was participating in the ocean the Ocean Virtual Dialogue, an event that was organized by the World Economic Forum. And the advisor of the minister asked me about, well, what is the velocity of ocean acidification along the coast of Chile? So I have to say, we don't know. We don't know, because the early kind of information that we have is information about carbon chemistry from research cruises, which is in a way is a kind of snapshot, information from very short time series, like 1 year or 2 years of buoy deployments. But we don't have, I mean, long time series, like 10 years or 15 years to evidence, you know, and to show to the community and decision makers the progress of this phenomenon on the coastal ocean. And at the same time, that's involved, that's, you know, on occasion, decision maker don't commit, you know, with a long-term program of observation, because in some occasions they feel that something is occurring in the region. People is measuring pH, is measuring carbon dioxide, is doing experiments. Well, they need, you know, a long-term program to try to deal with this issue, and that is very important for us. I mean, the scientists need to play an important role in how we communicate, you know, to the decision makers. The time scale of ocean acidification is longer than only, you know, measuring natural variability.
Rodrigo or Wilmer, anything to add?
Yeah, just a little bit. I completely agree with Cristian. I think it's, and Carla and Francisco, I think it's similar here in Brazil. And normally we don't have a continue our monitoring program. So some of the forces we have and we show in the presentation, like the GOA network sites, is constructed from our efforts, because the financial research is not to have the long-term monitoring program for that perspective and to understand ocean acidification, but for specific projects that start and end in a period of 2-3 years, if longer, 5 years, no more than that. So that is difficult. But in the case of Brazil, there is some kind of national institutes that it's a good opportunity to put all the researchers together. Each we are in different institutions along the country, and also some of the governance plan for coastal zones or for the oceans. Even NOAA is an abstract concept on all of those governance plan. Every time we try to insert OA on that. So those networks, several networks or the National Institute has collaboration with our main needs, that is to understand and measure OA and which is the impact in a variety of things, social, economics, even on biology.
Bueno, en relación a los estudios de acidificación y las pesquerías, por lo menos en el mar peruano, es poco, ¿no? Excepto de algunos moluscos como concha de abanico, pero falta una serie más larga de estudios. Lo que sí se avisora, y porque así lo señala la bibliografía, es, por ejemplo, nosotros tenemos la pesquería del calamar gigante, ¿ah? El calamar gigante, que es una pesquería importante en el norte peruano. Entonces, probablemente este se ve afectado en sus estructuras calcáreas, como los estatolitos, por ejemplo, ¿no? Y eso sí tendría que ver mucho porque el recurso prácticamente se desorienta, se dispersa, básicamente, ¿no? Y puede ser afectada realmente esa pesquería, ¿no? Ahí hay que también hay esa parte apuntar un poco más.
Okay, thank you all for answering that question. We have about 5 minutes left, so I'm going to do a couple more questions. We have quite a number of questions, so if we don't get to them all, they'll be moved over to the OAIE, and we'll continue the conversation there. This next question is for Francisco, and it comes from Cristina Herbon from JNCC. She asks about the work in Colombia, the study of variability of carbonate chemistry in seagrass ecosystems. Have they found any correlation between carbonate variation over time and impacts on the condition or extent of seagrass beds?
Okay, I'm sorry that I'm not the person to be able to respond this question, because I'm working in Ecuador, and for this presentation we ask for the information of the different colleagues, and they send us some information about this research, but I cannot respond specifically. But we could make in contact later to give the contact for the persons in Colombia that are working in the subject, so you could go in deep in that. So.
Yeah, that's actually a good idea. Christina, if you're on and you're listening, you should join the OAIE, and I will make sure to connect you and Francisco, and maybe Francisco could connect you to whoever's doing that work in Colombia. Okay, so the next question is for Wilmer, and it is, how does El Nino events affect upwelling of corrosive waters in the Humboldt Current? And the question comes from Fernando Lamego.
Bien, en este caso, cuando ocurre el Niño, ingresan aguas un poco más oxigenadas, ¿correcto? Más oxigenadas. Eso es un alivio, por lo menos, para los organismos bentónicos, de hecho. Y quizá también estaría disminuyendo un poco el impacto en la zona de mínima de oxígeno, por un lado. pero también es importante porque con el Niño, la contracorriente de Cromwell, que viene de la parte ecuatorial, avanza no solamente de Paita Sechura, sino más hacia el sur hasta Chimbote inclusive, ¿no? Y mejora recursos como la distribución de la merluza peruana, por ejemplo, porque resulta que la corriente de Cromwell tiene por lo menos un poquito más de oxígeno, 1 mililitros por litro, que es más de lo que sale con las urgencias costeras. Y de hecho, las urgencias costeras no ocurren durante el Niño, ¿ah? Lo cual es importante porque ya no hay ascenso de aguas ricas en CO2, con pH mínimo, aguas corrosivas. O sea, en cierta manera, el Niño es un alivio para atenuar un poco el impacto de las aguas corrosivas.
Thank you, Wilmer. And I think we'll squeeze in one more question. This question is for Carla, and it comes from Libby Jewett. She's asking how many ships you have instrumented so far, and just how are your OA observations going?
Okay, so thanks, Libby, for the interesting opportunity to show off our ship. So we have incorporated recently, 2 years ago, an underway PCO2 system on Victor Angelescu, which is the main ship and the new one that we have in our institution. That it's also very important because it's the first also to have new equipment in Argentina. Actually, there's like 5/6 ships available to do oceanographic research in Argentina, but it's the only one that has an inbuilt system for ocean acidification related studies. But it's going to be, but some other institutes are having new technology that can be on board, that can be taken on board, you know. So, and I would like to mention that something important about this, and in many ways, thanks to Libby, we, through the peer-to-peer mentoring, we had the luck to have Dennis Pierret training us to, and now the PCO2 system is acquiring really nice data. That I put a slide, but it was not that, maybe I didn't highlight that enough, but we have at least good coverage of the Argentinian sea in the last 2 years.
Great, thank you so much, Carla. At this time, I'd like to thank all of our speakers one last time. Thank you so much for the wonderful presentations. To our audience members, we'll be continuing the conversation on the Ocean Acidification Information Exchange. And it's not too late to register for the last 4 sessions of Ocean Acidification Week. We hope to see you there. Thank you all very much, and we'll see you very soon. Bye.
Bye-bye.
Thank you. Bye.
Bye-bye.